Okay, hello everyone. This is the first video reviewing for our Unit 1A test. I'm going to break it up into at least 2 videos just to make sure that they're not too long and it's easier to find the problems. So let's just go ahead and hop right in. It says, determine the domain on which the function is decreasing. So the function is decreasing, so that's going to be this highlighted portion here. So the function is decreasing on this portion here, highlighted in green. And remember, you read your graphs, read graphs left to right. Okay, and on this, I'm looking at that point right here. So it is decreasing from -4 to infinity. And here I switch at -4, and that's why I use a parenthesis. So the function is decreasing, going down from -4 to infinity. So we have the graph of our function below, and it wants the average rate of change of this function on the interval. So what I'm going to do here is find where x is 0 and 4 at. X is 0 here, that is. And notice if you mess up anything, notice that is a jump of 4, so this is going up by 2. So this is at 0, 10. And then at 4, I'm at 4, 2. So if your answer doesn't look like mine, it's probably because you didn't pay close attention to what the interval is, like what the y scale is. So using that, I'm just going to write that the average rate of change is equal to, let me zoom in a little bit. So the average rate of change here is going to be delta y over delta x, which is 2 minus 10 over 4 minus 0, which is -8 over 4, -2. So my average rate of change here is -2. Next, given the function is defined in the table below, find the average rate of change again. So it gives us an interval here, 1 and 7. I'm just going to do the same thing. Average rate of change, let's go to delta y over delta x. So remember, I usually tell you to do, you can do it either way as long as you're consistent, but I usually do end minus start. So the end here is 7, so f of 7 minus f of 1. 7 minus 1. So my function output at 7 minus the function output at 1, which is going to be 64 minus 10 over 6, which is 54 over 6, which gives me 9. Okay. So my average rate of change from 1 to 7 is 9. So now, working with our odd and even functions, just to remember a couple notes before I even read the problem. Even is equal, and odd is opposite. And what it's talking about here is the y values. Okay, it's talking about the y values. So, if I look at what this is saying, it says if f of -7 is equal to f of 7. So, what that's saying is, look at what's in parentheses here. So when x is -7, so when my x value is -7, it's the same thing as when I get the same output when my x is -7. And these are opposites, so opposite x values, so x and -x, give me the same y values. Okay, so that tells me that it is even. okay? Opposite x values, 7 and -7, are opposite x values, and they equal each other. So whatever the function outputs at 7 and -7 is the same thing, even as equal, so I know that this is even, okay? And that kind of leads you to think, well, if that one was even, this one's probably odd. But let's walk through the notes again. So if I'm thinking it's odd, I know odd is opposite. And what I have here, once again, highlighted in green here, I have opposite x values. You always have opposite x values, but it's the y values I'm concerned with. So this is saying that opposite x values have opposite y values. How do I know that? Well, look at my arrow right here, okay? So highlight this in pink. So notice, I'm seeing the opposite of f because I've got this negative in front of my function here. So in function notation, that's saying negative f. And here on the left side, it's missing a negative. So I have opposite y values. So opposite x values here give you opposite y values, so that tells me that it's odd. Okay. Now here we have a graph function, and it says which function could represent the graph below. And then I have factored form. That should instantly tell me I should look for my zeros here. So I've got a 0 at -1. I mean, not at -1, at +1, sorry. And it bounces. So that should tell me x equals 1 with a multiplicity of 2. So x equals 1 with a multiplicity of 2. Then here, I've got x equals -2 with a multiplicity of 2. I mean of 1. So that crosses, because it crosses, that's how I know that. And then here, this is x equals -3 multiplicity of 1 because they cross. And I don't know that it's 1, but usually, like, I just know that it's odd. Like right here, my multiplicity is odd for the first two. And then at x equals 1 right here, I know that it's even. But for simplicity's sake, we usually use 2 for even multiplicity and 1 for odd. So if I go down here, remember I've got to flip my values. So instead of -3, I'm going to have f of x. Parentheses are liars, so parentheses are liars, like always. So instead of -3, I'm going to have +3, x +3, multiplicity of 1, don't need an exponent, multiplicity of 1 again, so instead of -2, I'm going to have +2, and then here, I'm going to have x -1, multiplicity of 2, so squared. So I'm looking for whatever has x -1 squared, so that eliminates this and this. There's no squared, and it's x -1 squared. So it's probably this one and not this one, but let's check the rest. +3 and +3, +2, +2. Boom. So the answer is A. So then it says, describe the end behavior with words. Okay. And this might seem a little weird, like, what do you mean by that? Well, let's think about our inputs and outputs. So let's graph, like right here, this pink portion, okay? What this is doing is, because I'm moving to the right slowly, and as my input increases, and you'll see it called without bound. So as input increases without bound, output increases without bound, okay? So as the input increases without bound, as my x gets bigger, my y also increases, my y gets bigger. And it's the opposite here, right? Because this is an odd degree function, so they go opposite ways. So as input, so instead of increasing here, I'm decreasing. So I'm going to the left here. So that's how I know down here I'm decreasing. So as my input decreases without bound, output decreases without bound. So as my x's decrease or get more negative, so do my y's. My outputs, my y's decrease without bound. Cool? Okay, just a couple more on this video. At what values of at what x values is the rate of change equal to 0? So important reminder here is that the rate of change at extrema and another word for extrema here that you'll see is turning point or max and min. So the rate of change at my max and min, my extrema, my turning points is 0. So I find my two turning points. So right here and right here, that is 0, 0. And this is -2, 4. And I look at what the question wants here. It wants the x values. So x equals -2 and 0 would be the answers. Sorry about that. Would be the answers for this. Okay. Now, number 9. Imagine you were walking directly downhill from a mountaintop. So when they have problems like this, I always like to draw it. I'm not an artist, but it helps me a little bit. So I've got my pretty little mountain here, and then we got me. Boom. So I walk down for 10 minutes. So I go down for 10 minutes. And then I pause for a 5-minute break. So I'm just going to chill here for a little bit. So my 5-minute rest. And then I walk 20 minutes down more for the rest of the way. Okay. And then I'll walk down 20 minutes for the rest of the time. Till I reach the bottom. Okay. So now let's put that in a graph to make it make more sense too. You don't have to. But I think it makes it a lot more helpful. So the height, it says if you made this into a function, the height is y, time is x. We would have we'd have height over time. So in this case, look at me on top of the mountain. I haven't moved when I'm here in yellow. I'm at the main top of the mountain, so I'm as high as I'll possibly go up here. And then I move down for 10 minutes. Let's say I go at a constant rate. We don't know. Maybe I'll go slower. Maybe I go a little slower at some points, but I'm always going down for about 10 seconds. Then I rest. So when I'm resting here, circle that in red. So my resting period here, my height isn't changing because I'm just sitting there, catching my breath, getting my water in. And then for the last 20 minutes, I'm going down. Okay. I go downhill for the rest of the time. So, it says, if I made this into a function, which two of the following are true? So the function is, let's read this one. The function is sometimes increasing and sometimes decreasing. Well, my function here is only going down or staying constant, all right? So my function is only decreasing and constant. So this one can't be right. And that's exactly what this next one says, though. My function is sometimes decreasing, sometimes constant. True. My height decreases at every moment. That's not true, right? Because of this little green portion here, my constant portion. I'm not decreasing there, am I? So that one's not true. And then let me erase my little drawing here. It says your height never increases. Well, if I'm always decreasing and I'm always constant, then yeah, I'm never increasing. So the answers here would be B and D. Okay, one more. So it says in the table below, is the function concave up or concave down, and how do you know? Well, let's think about this for just a second. We know concave up, my definition for that is that my rate of change is increasing. Okay. And for concave down, my rate of change is decreasing. So to find out if it's concave up or down, I need to see what the rate of change is. So what's happening here? Boom, boom, boom. And I'm not talking about what my function does, because my function is slowly increasing, right? But that's not what I'm asking about, because I'm getting from here to here, I'm getting less and less negative until I eventually switch to positive. I'm not talking about the function itself, I'm talking about the rate of change. So my rate of change here, negative 23 to 14, so this portion here. So from 23 to 14, I went up 9, so I went plus 9. And then from 14 to 7, negative 14 to negative 7, I went up 7. And then from negative 7 to negative 2, I went up 5. And then negative 2 to 1, I went up 3. Okay, and you might pause here and think, well, okay, I've got a bunch of positive numbers, my function's increasing, so that's concave up, right? Not quite, because my first difference here is the same thing as my rate of change. So the first difference is rate of change. Okay, and now, because remember, concave up and concave down are talking about what happens to the rate of change. So it's always dependent on this second difference here. What's happening on these yellow jumps? So from 9 to 7, I went down 2, I went down 2, and down 2. So here on my second difference that I just found, highlighted in pink, I know I went down 2. So what that's telling me is my rate of change is decreasing. So it's concave down. And that's exactly it. So it's concave down because the rate of change is decreasing. Okay, and that'll end this video here, and you can go to the next video for the rest of the packet.